We're going to talk about object modeling in this presentation. We'll take a look at not only how to represent classes in UML diagrams, but also what to represent, why we should represent, various other details. The purpose of this presentation is to keep it extremely lightweight so we can use the design tools effectively rather than being burdened by them and create a monster out of it. So as you get to use these tools and techniques, use caution. Try to always ask yourselves, is this information useful? Are we creating something that's practical, that can be used effectively? The goal is not to create a heavyweight documentation. The goal is to really communicate, and as a result, using that communication to create better software. So let's talk about object modeling. Object modeling is a very fundamental thing that we do every single day. Whether you draw a diagram or you simply sit down and write code, you are doing object modeling. It's impossible to create code without modeling. Modeling is a representation, abstraction, an idea that we come up with and then we represent that in code, and it's a way to express our design ideas. We use modeling constantly every single day in what we do. We cope with complexity using models. We create abstractions and relationship between abstractions, and that's what we do every single day. So what is object modeling? Object modeling is a way for us to cope up with the complexity of what we are building, a representation, so that we can communicate those very effectively. We use models very often. In real life, we use models to represent various concepts. For example, we may use a little peg to represent whether a certain action has happened. We use post-it notes, hanging around on monitors, and we jot down things as we go through things. And we move papers from one place to another with a signature on it. So we represent various things to cope with complexity and different stages of operations. When it comes to programming, object modeling is very useful to represent design ideas in a way we can communicate and then move on to implement those in code. An object model is a static structure. Now, there are various different models people often create, and in my opinion, a lot of those things are unnecessary in most of the situations. There are some situations where one particular model is quite useful, but we have to really use our common sense and apply pragmatism in creating these different types of models. And an object model is a static structure. We're going to talk a lot more about object model moving forward, but let's talk about other types of models we often create. A use case model is very useful to talk about how a particular feature is implemented. We could have interactions between actors in a system and the system itself. It's a way for us to describe a series of interactions. Within the system itself, we often create what are called sequence diagrams or interaction diagrams. A sequence diagram shows the flow of a particular function through different objects and methods. A sequence diagram can be very helpful in an extremely complex situation. But for most of what we create, a sequence diagram is an overkill and a waste of time. A sequence diagram can help us to say when a user logs in, which class first handles the login, if there's a filtering operation being done. For example, when somebody visits my site, I want to provide access to, let's say, their presentation details, however, only if they are logged in. But how do we deal with the situation whether they have logged in or if they're a casual visitor or if they have logged out already? Well, I don't want to be implementing this code in every piece of logic. It becomes enormously complex with duplicated code. So almost every single class in my system has a filter. So when a user makes a visit to a particular class to execute a certain method, the filter kicks in, checks it to see if all the necessary credentials and data are available. If it's available, the filter lets through and other operations are performed. If the filter says, nope, the user information is not available or I don't have enough details about this particular presentation, well, the filter will then reject that particular request and reroute the call to yet another handling object. Now, in order to explain this, we could draw a sequence diagram. A sequence diagram will show a request coming in with one example of a user information being present. The filter will then execute and then pass the request nicely to the next method. And so we can show that as a timeline as to what operations come in, what methods handle it, and where the request goes next in the timeline. So in a sequence diagram, we have objects vertically placed, and then the horizontal timeline shows the interaction between these different objects as a sequence of operations. If the user credential is not valid, the filter would take action and then route it to yet another object rather than passing to another method in the same object. That would be another sequence diagram to illustrate that scenario when the user information is not available. So sequence diagram can be very helpful to explain some of these scenarios, but I would normally use them only in select situations where such interaction need to be explained to somebody, but I wouldn't be sitting there and drawing the sequence diagram for every single code that I'm going to write in my application. If you ask me when have I written a sequence diagram, I would say probably I write a sequence diagram once in a couple of different years when I'm trying to really capture something extremely difficult for me to comprehend in my head. But that doesn't mean that we don't really do sequence diagrams at all. Oftentimes, I would be sitting next to an engineer or a developer rather, and then we would be talking about a certain situation, and immediately we'll grab a napkin and draw a little sequence diagram to illustrate what's going to be happening. And oftentimes, that's quite enough for us to comprehend the details and move on. So very rarely do we need to capture that. But there are other situations where we may be working in a very critical audit situation. Maybe the government agency, Federal Drug Administration, for example, or another agency, a taxing authority, may want to go through and verify certain critical operations are being done properly, in which case we may be creating some of these interaction diagrams and sequence diagrams. An interaction diagram is different from sequence diagram in that we show the interaction between objects, not necessarily through the timeline of what methods are being called, but which objects collaborate with other objects to get things done. For example, I go into a driver's license office, a clerk at the front desk may check my credentials and then may send me to the counter where I pay for the service, and then I come and wait in line, and then maybe an officer will come and help me to take my driver's license test. So in this case, this interaction diagram is between the clerk and the person who processes the accounts and the officer. So you could show that these are the interactions between these different objects. But when it comes to object modeling, it is a pretty static structure on the other hand, and that's what I will focus on mostly in this presentation. An object diagram and a class diagram represents how classes and objects are placed and interact and what is the relationship between them and what they really contain. So we predominantly focus on objects and relationship between objects when it comes to the object modeling. And class diagrams are one of the most common diagrams we often use. Again, whether you hand draw them or have tools generate and reverse engineer from code really depends on the context. But whatever you do, I would strongly encourage that you keep this extremely lightweight so that it doesn't become a burden to create and burden to maintain it. So use your judgment along the way, what to put and what not to put, and be very reluctant in showing details. You want to make sure that the details you show are extremely valuable from the point of view of the person looking at the diagram and practically using it. Now, clearly this is easy for us to understand. If your diagram is polluted with enormous amount of details, then the person looking through it is going to have a really tough time looking at the essence versus waiting out the details they don't need to look at. But a really good diagram really keeps the focus of the person looking at it so that it brings out the essential characteristics very quickly so the person looking at it can make the decision that they need to make and move on very easily. So what do you show in a diagram, an object model diagram, a class diagram, for example? Well, show only the most important details in a class diagram. Remember, a class diagram is not a full representation of the system, but the most essential aspects you would really like to show. For example, if you're trying to, if you, let's say you meet a friend after a very long time, and in the meantime you have bought a new house and moved in, and you're trying to explain to a friend where your house is and how it is laid out and where it's facing, what are the details you would be presenting to the friend? You wouldn't be telling about every single detail, about specific dimensions of every single room to the inch, or you wouldn't be talking about very specific colors of every wall in the room, but instead you would talk about, how the house is placed. If it's on the top of a beautiful hill, you would specify that. A directional component, if that's important. For example, my house is facing in a direction where it doesn't accumulate a lot of snow in the front, and that is something to think about and talk about if that is important to when talking to a friend about it. And on the other hand, you could also specify about how many floors you have in your house, what's in your basement, if your basement is built or if it's vacant, and things like that. You would be communicating, again, very, very high level features that are providing enough details not to really bog down the person looking at it, but to really help them to make good decisions out of it. So the most important and essential details should go into an object diagram, into a class diagram rather. When do we use such a diagram? We often use this diagram in two phases. During an initial design phase, a strategic design possibly, we could draw these diagrams to brainstorm a certain idea and say, well, looks like this could be a class, looks like this could be connected to this particular other class. Maybe these are the attributes we would probably want in this particular class. So you come up with the initial strategic design, and you could create this as a way to represent your design ideas and talk about pros and cons and evolve the design. So that is one place where we would normally create for brainstorming purposes. The other reason we would create this would be where we are using this as a communication tool, where you have a new member in the team or somebody who's been working on a different part of the system is coming back to look at the part of the system you're working on. So it's a nice communication tool to say, well, here's how things are related, and this is the class that talks to this other class. Here's the responsibility of this class. This class receives that particular service and uses that information. So it gives a nice way for us to describe the relationship of classes and how they interact with each other. So it serves as a nice communication tool to convey the intent. So in this case, you could either have a diagram that you use to communicate this, you could draw a quick sketch to communicate this when people ask you questions, or you could reverse engineer the diagram from the code and then extract the minimum details and then use that in your discussions. So that could happen as well. So given this object modeling, as the word indicates, the core component in an object model is objects. So what's an object? Well, an object is something that represents an abstraction and stands in for something in the application. It could be something tangible, like for example, you could say a coaster, and I could say there's a coaster and I can have an object of a coaster, but it doesn't have to be tangible things at all. We often represent things that are intangible in using objects as well. For example, a particular thought or an idea or a particular fragment of message passing through a message queue in transit could become an object as well. So what is an object and what is not an object is very contextual, and we have to decide that based on what we are trying to model. Well, in object-oriented programming, we often decompose a system using objects. Objects have identities, and so you can represent an object and say that object is different from this other object. Like there could be people and you could clearly say one person apart from another. Even in the case of very identical looking twins, we got different identities for them. So definitely objects have identities, and our identities are represented in different ways in different applications. For example, all the presentations on this particular site are unique in the title of those presentations. All the users in the system are also unique based on various other aspects of the users. So there are identities for presentations, for users, and various other things, and every object has a unique identity. Oftentimes in a database, we use primary keys as identifiers. In the case of programs running, the main memory location could be identifiers, but oftentimes a domain-specific identifier is often used to distinguish one object from another. But when we do object decomposition, we take the problem on hand and assign responsibilities to different objects and say, this object is responsible for this kind of behavior and state, and here is this other object responsible for another behavior and state. For example, a presentation object may be really in charge of keeping track of presentation details, the title of the presentations, for example, the file for the presentation, the topic related to the presentation, various other details, who's the presenter. But the presenter itself becomes another object. For example, Venkat as the presenter could be very different from another presenter. So a presentation object has a relationship to presenter object. On the other hand, a presentation itself has its own properties which become its attribute. For example, how long is this presentation is a detail of the presentation object, if you will, if we represent that using objects. So when it comes to decomposing the application, we can usually decompose this based on the domain knowledge and the usage patterns. For example, in a presentation domain, presenter is an object, presentation is an object, a user is an object. On the other hand, the duration of a presentation is not an object. It is more of an attribute of an object, a value within an object. So we can pretty much figure these out most commonly based on the domain and the usage pattern. Sometimes, though, it's a bit confusing whether something should be an object or an attribute within an object. And then we have to really look back at the usage pattern. Does this deserve to have its own identity? For example, a presentation deserves its own identity, but the duration of the presentation doesn't really deserve its own identity. While a presentation would be an object, the duration of presentation doesn't deserve to be an object. It becomes an attribute within an object. So use your judgment based on whether you would pass this around as an identity separately and ask yourselves, does it make sense to stand alone, or is it something that's part of another object? So that's a way for us to decide whether something is going to be an object or simply an attribute within an object. There is no single correct representation of objects and object diagrams and relationships. There is no single representation for those. So we got to pick and choose based on the context and the domain and the bounded context we talked about in earlier presentations. So we got to make a decision based on that. Well, we talked about what an object is. A class is often a blueprint of objects. So for example, a collection of objects become a class, but the word collection doesn't quite convey the meaning. For example, I could put my coasters and napkins together. That's a collection as well, but that doesn't become a class. But instead, coasters are a class because they serve a specific purpose. There could be different kinds of coasters. I showed you one pale coaster here, but there could be a very decorated coaster and other types of coasters. But a coaster serves a very specific purpose. It is to place something on it. So you could say there's a coaster. I often drink coffee constantly when I'm working. So there's a coaster next to me on my table here, on my desk here, so I can have things on the coaster. So a coaster is a very specific class. When you talk to people, if you're going to shopping, you could say, I'm here to buy a coaster. People should understand what you're talking about if they're in the business of selling coasters, for example. So a class is a blueprint, a description of an abstraction that you're dealing with. How do you recognize classes in a system? Well, a class should have a very clear representation of an abstraction. It's got a very specific meaning in your application, and so you should be able to represent these classes in your system. Classes often have state, but they also have behavior, and so you could capture the state and behavior into a class, and that's how you could represent them in your application. But typically the way to represent classes or identify them or recognize them is classes often appear as nouns in the problem statement. Be careful using this though. You don't want to get into a mechanical process of just going through the requirements and outlining or underlying nouns in the problem statement. But typically classes are nouns in a problem statement. Like a coaster, for example, is a noun, so that could represent an object in a system. My smartphone could be an object or a class in a system, and so on. So oftentimes these are nouns. When creating a class also, try to name them as nouns so that you know that they represent something. So usually methods are verb forms, whereas classes are noun forms in applications. But again, be careful. Just because you see a noun, it doesn't mean it's a class. It could be an attribute of a class as well. So that's contextual. We have to decide that. But classes have a very clear semantic and meaning, and they have abstraction to represent details in the code. And we got to pick and choose based on what these things mean based on the context and the usage pattern that we talked about. So how we interpret a particular class definitely varies based on the context. It depends on the application we are developing. Whether car is an object or not depends on the application we are developing. And for example, in an application where you simply want to count for the number of assets a person has, like for example, for taxing purposes, I need to often give to the government details about what kind of assets my company owns. In that case, these assets are purely a ledger entry. They don't really survive as a separate object. A printer, number of printers that Venkat has or Venkat's company has, number of cars that are being owned and stuff like that are simply items. On the other hand, in an application where I'm simulating various different automobiles, maybe a car will be represented as a class, so it depends on the application. But here's another fun thing. How a particular object model is created depends on the person modeling. So here is a bit of a thing that could, surprise most of us. If you give me a problem to me and ask me to design it, I would come up with the design today, and maybe you can note it down, and then maybe 6 months from now or a year from now, get back to me, give me exactly the same problem and ask me to design it. The chances are the design I would come up with is not exactly the same. So even though the problem is exactly the same, the person designing is exactly the same, the time of designing is very different, and we load up different contexts in our head. There are things I would learn possibly in 6 months or a year from now, and that may influence a redefinition of the context in which I'm seeing the problem. So if we were to come up with exactly the same design every time we look at a problem, humans wouldn't be designing software, machines would be doing it. So it really is also dependent on the context and the person, and what the person is perceiving at the moment of design can greatly influence what we create. Now, it wouldn't be the same design we come up with every single time, but hopefully there are certain things we can look at in terms of how to better design. And so there is probably a little circle of better design, and the designs will come into that circle. And that's what we're going to be looking at as we go through other presentations and look at some of the ways we can improve our design. So when it comes to these objects, we can create these instances of these classes. Typically, a class can have any number of instances, 0 instances, 1 instance, many instances, thousands of instances, for example. So in my application at any given time, I could have thousands of objects floating around of different types. However, there are certain types for which there will be only one object at any given time. Oftentimes we call them as singleton. A singleton could have one object or a very small set of number of objects in the application. So that could be what a singleton has. On the other hand, an abstract class will have 0 direct instances in the application. An abstract class is useful to model a certain concept that gets implemented and extended, but we wouldn't have an object of that type itself. For example, we could identify men in the room, we could identify women in the room, but all of them are human, but there is no explicit instance of a human in the room. We all get classified as either men or women. Likewise, we could say there are dogs in the room, there are cats in the room, all of them are animals, but there are not one thing that is just an animal. So human, animal, and things like that are abstractions and abstract classes, and abstract classes really are classes for which there wouldn't be any direct instances, but there are other types often derived from them for us to use. So we talked about classes and we talked about objects. We often represent them in diagrams. A class diagram is a diagram that shows classes and the interaction between classes. Object diagram is a diagram that shows interaction between objects. We often create class diagrams, but occasionally we would create object diagrams as well. I already mentioned about one object diagram, which is the interaction diagram. So an interaction diagram is often an object diagram we create. So what are object diagrams? Object diagrams often show objects and relationship between objects. For example, you could say, here is Joe the clerk, and here is the Jacob the officer, and here is Sarah the director, and you could show the relationship between the three and how they interact with each other. Now, director could be a class potentially. For example, officer could be a class separately in this application, and clerk could be a class separately. But this particular diagram shows how these three interact. Or, for example, you could say, here is a manager, Sarah, and there are three different clerks. Jacob is a clerk, maybe Bob is a clerk, and Julie is a clerk, but all the three are working with this manager, or in this particular context, that could be a relationship being shown between these different objects. So this is very useful to document test cases or example scenarios of execution, but these often are used to clarify complex behavior that could get very confusing looking at a class diagram, but the object diagram can show how these things actually interact with each other. So use the object diagram when you need clarification or you are compelled to show a specific instance or interaction between objects. Do not create object diagrams unless you need to explain some intricate relationship, so use that very sparingly. A class diagram is what we use most of the time to create the relationship, a set of static relationship between classes. Now, keep in mind that such a diagram should be very concise, easy to understand, and very, very practical. So the goal is not to dump everything into a class diagram. The more a class diagram has, the less effective a class diagram often is. So keep it extremely lightweight, minimum and essential when it comes to representing it. So how do you represent a class in a class diagram? So let's take a look at one example here. Let's say I want to represent a person in a class diagram. So I would draw a class diagram in UML notation. So UML stands for Unified Modeling Language. And Unified Modeling Language is simply a language. Well, the word language is a bit misleading here if you really think of programming languages, but languages are often used for communication. So a UML is a Unified Modeling Language to communicate design ideas. Before the time of UML, there were a few other things like Booch diagram invented by Grady Booch, and object modeling language invented by various people like Jim Rumba and others, and those had different representations. Well, if you worked as a programmer about 25-30 years ago, you had to choose between one of these modeling languages, and the pain was that you got comfortable with one, and when you went to talk to another team, and if they used a different notation, it often caused confusion. In a Booch diagram, which is what I grew up using, we would use clouds to represent classes. That was really nice. I really liked it. Because if you're hand drawing, it's really hard to draw a perfect square or a rectangle, but you can never go wrong drawing a cloud, isn't it? So you use clouds to represent classes, and relationship between classes was also represented using these notation. In the object modeling language, on the other hand, you use rectangles to represent classes. Well, in UML, you are using rectangles, so you know where that particular concept came from. So when UML was created, all these people who were behind modeling languages got together, and they decided to create this one unified notation. A great book to read in this area is UML Distilled by Martin Fowler, and as the name indicates, the word distilled, you don't want to really get sucked into UML. You want to really distill and use a very lightweight representation for good communication. So take a look at UML Distilled if you're interested in that. So in this case, I've created a class called person, and so I have said that my class is actually a person class. The plus simply indicates that it is public visibility, so it is available outside the classes, the packages and the namespaces to be used. So typically a class notation contains three compartments. The topmost compartment tells the name of the class. The second compartment right in the middle shows us the attributes or fields of a class, and the third compartment often shows the methods or operations this class is going to have. Well, in general, when I draw object diagrams, I don't care to show methods and attributes. So oftentimes I would simply click on the show and I would hide all the compartments and I would only have the class name floating around. So likewise, for example, I might create another class. For example, I could say I have a class called car, and I could again once more say, do not show me all these other things, only show me the class car alone and not anything else, for instance. So for example, we could say in this particular case show, and I could ask it to only show me the class name car and not any other details of this particular car, for instance. So we could represent the person class and we could represent the car class. So this becomes a class diagram to represent these different details, if you will. So this can be a very nice way to represent only the necessary essential details. So we looked at representing a class. Next, I want to talk about showing attributes. An attribute is a data value that you often have within a particular class. For example, I may say that a person is going to have some attributes. So in this case, I would say show the attribute compartment. Remember, that's a second compartment. And here I could say, for example, age, and then I could say integer as the age of the person. Now, some people would argue that should be a long and not an integer. Well, whatever data type you want to specify, you could specify that. You could specify it as an int like this. You could say int in lowercase, whatever that you feel is a better representation, you can communicate that. Now, clearly in this case, we have created an attribute. An attribute is a data value. So you could say this person has an age, but this person also has maybe yet another attribute that you would like to specify. So for example, we could say this particular person has, in addition to the age, we could say that this person has maybe a height. So we could say height, and we could specify what the height is. Well, we could represent the height as integer as well. If you simply want to represent the height in maybe centimeters, or you want to specify the height in inches, you could simply have an integer. If you want to be very precise, you could also have a floating point representation, but that's your choice. You could represent that as well. So these are merely data values. You may have different values for different instances for these particular attributes. For example, my height would be different from the person who is next to me. My children are different height than I am, and so on. So we have different people, but the heights of different people are different. Likewise, age. So we have different people in the room, but you could see, look around, and people are of different age in the room. Some of them are born a few months from your date of birth, some born a few months earlier, some maybe a year later, some maybe many years earlier, and so on. So different objects have different values for these attributes. The names of the attributes, however, are often unique within the classes. You would not have two height values or two age values. Sometimes you have similar properties, but you give them unique names so that there's no confusion. So you could have different values for them. For example, if I want to say color, well, color of my hair is different from color of my eye, for example, which is different from the color of my skin. So I may have color of skin versus color of the eye versus color of the hair. And oftentimes, if I'm filling some government records, they often ask me what's the color of my eye, which is different from maybe the color of my hair, for instance, and things like that. Well, when it comes to these values, adjectives often appear as enumerated values. For example, what's the size of a shirt, for instance? Well, you could say the size of a shirt is, and I could give specific inches of my shirt size or in centimeters. But oftentimes, I don't really care to really use the specific size. If I'm really trying to get a very formal clothing, I might go into that particular measure. but oftentimes I go to a store and I ask for either a small shirt or a medium shirt or a large shirt, an extra large shirt or an extra large shirt. Well, the size in this case becomes enumerated set of values where the values could be small, medium, large, extra large, extra large, and so on. So these could be enumerated values, and oftentimes these are used as adjectives like a red car, a blue car, or a white paper and stuff like that. So we could have these kinds of enumerated values rather than arbitrary values that we give. Well, we often represent pure data values as attributes. Sometimes in the case of languages like C++, we call them member variables. In UML and modeling, we call them attributes. Let's clarify that for a minute. The word attribute can be a bit confusing depending on the language. In object modeling, an attribute is a property of an object. In the case of C++, we use the word member variables. In the case of Java and C#, we often use the word fields. Now in C# itself, there is something called attribute, which has nothing to do with this attribute we are talking about here. The attribute in C# is actually annotations in Java. So languages tend to use different terms. So in general, attribute in object modeling is a field in Java, field in C#, member variable in C++, but keep in mind attribute is a data value that we represent, a pure data value. Objects that are related, if you want to represent something which could be an object, then it's better to represent it as a relationship. But we got to be a bit careful how we deal with this. For example, if I have a person, and if the person has a height and an age, I would represent them as attributes. But if a person has a car or many cars, if car is a separate identity in my application, I wouldn't place car over here. So for example, I would not create car like this. So don't do what I just did here. That's not a good idea. So instead of that, what I would recommend is, oops, I didn't mean to delete the entire person, but instead of that, what I would recommend is you have the person sitting here, but do represent the age of the person if you would like. And you can also represent, for instance, the height of the person if it makes sense to represent that here. However, for the car, do not place the car here if car has separate identity in your application. If car doesn't have a separate identity, sure, that could become pure data value. But if it does, you probably want to represent the car separately and have a relationship between those two. We'll talk about relationships later on. Now, don't show internal identifiers in your class diagram. So don't put ID, for example. If every object has a primary key, I wouldn't care to show an ID in here. So for instance, I wouldn't create an ID as a field to represent here, attribute to represent here. I wouldn't be placing that, for instance. Likewise, so instead of showing the identities, assume those identities because based on the context of the application, based on the context of the application, we know that we have these things. You don't need to represent that in the diagram. Don't show every single attribute also. If your class is going to have 6 or 7 attributes, don't feel compelled to list all of them here. The goal is not to show everything. The goal is for a diagram to communicate the most essential details so that we can practically make use of that. So only show things that are very highly relevant and useful for the person viewing this particular diagram. So what do we really show in this particular class diagram? Well, the visibility of the things we want to show is also something we may want to specify here. For example, do you want to make the age a private field or an attribute? Then you would place a minus in front of it. So if you look over here in the bottom, you can see that there are different things specified here in terms of the visibility. So you can see here is public, for example, and package, for instance, and you have various other details being presented here. So based on what you're trying to model, you could have various of these representations in here. for instance, if you want this to be private, you could specify this is private. So in this particular example, you can see that the person's age is being displayed here as a private field. So you can see the word, the little radio button private showing us the detail. On the other hand, I could go back here and say, well, I don't want this to be private. I want this to be public. And you can see that a plus represents a public right here. Likewise, you could say, well, I don't want this to be public or private. I want this to be maybe protected. And you can see that that becomes a protected notation as well. Or you could say, no, I want this to be a package visibility and not a protected. Now, in other discussions, I've shown you how in languages like Scala, you can make a particular variable either private or package friendly, or you can make it protected. Well, that's kind of what the modeling language allows us to do here. Whether you can do something like this in a language or not depends on the language. In the case of Java, a package protected is when you don't specify anything at all, like public, private, or protected. You don't specify anything at all. So for example, if you're interested in seeing how this is going to look like in the case of Java, you could take a look at it. For example, say, show me like you would do in Java. Notice there is nothing in front of it, so that says it's package protected, package privilege. On the other hand, if you really want to make it protected, you could select that and say it's protected, and notice it says the word protected for Java. So you can see the notation in UML and the underlying representation for different languages, and you can pick and choose that based on the language implementation you are interested in. So that shows us how we can specify the various privileges that we want to specify for the attributes themselves. So we talked about what these attributes are, and these are pure data values that we would like to represent. Likewise, there is what is called the derived attribute. Well, it is misleading because at first sight, we may think that derived attributes are attributes in a derived class. Well, the word derived is very misleading. A base attribute is an attribute of very primary, preliminary attribute that we create. For example, we could model this as date of birth and say date, and you could argue that date of birth, obviously I would like to keep that as a private field, if you will, and the date of birth becomes the base attribute or a primary attribute that you are keeping. A computed value becomes a derived attribute. For example, how old is a person? Well, you could say that the age is not being stored in the object, and you could say that derived is age is a derived attribute. So you could go to a person and say, hey, do you know when you were born? And sure, every person has a date of birth, and they store it as in the object, and date of birth is a base attribute or a primary attribute. But you can go to that person and say, how old are you? And the person then would take the current year, subtract the year they were born, and subtract 10 more from it and tell you how old they are. So the point really is the age is a derived attribute which is based on the base attribute called the date of birth. So when it comes to modeling, we can decide whether an attribute is a derived attribute or a base attribute. In languages like Java, we often represent these attributes as properties using Java Bean convention. And when you call a getAge property, internally it would then do the arithmetic based on the current date and the year of birth and give you the detail of the derived attribute. So it depends on how that gets implemented language based, but the concept of derived attributes still exists. On the other hand, we can also have operations and methods. Again, these terms are used very interchangeably and can be confusing. Well, in C++, we often use the word operation like you're performing a surgery of some kind. In the case of Java and C#, we often use the word method. Well, at the very fundamental level, an operation is something you can do on an object. It represents a behavior that you could execute or exercise on an object. A method is often an implementation of an operation on an object. Again, we often use these terms interchangeably, but you could pick and choose these terms if that makes sense. So an operation is what you can do on an object. A method is a specific implementation of an operation. But like I said again, if you use the word operation or method, you can use them interchangeably. Don't get too hung up on the fine-grained differences between these. A polymorphic method is a method which is implemented differently on an object, but the same method is available on multiple objects, but the implementation varies. For example, you could say play, but what we play and how we play could be very different. That's a polymorphic operation, for example. Well, we have query methods. These are often represented as const methods in C++. Read-only constant final methods, well, actually, methods that don't do any mutation is what we're really after. There's no such real concept in Java or C#, unfortunately, but languages like C++ give you these methods which are const methods. Within those methods, you cannot modify any of the content of an object. Well, if you write a method that is a query method, but the main idea is by calling this method, you're not changing the state of an object. So for example, I could go here and write a method called getAge, and getAge is a method I wrote. It's a public method, as you can see, but it's also a query method. By calling getAge, you're not modifying the state of an object. Well, when you say what's your age, the state of an object, a person doesn't change when you ask for age. Well, actually, it depends. There are some people who get really angry if you ask about their age, so the state may be very different. They are really angry at you. But nevertheless, the idea is that when you call a query method, you're not affecting the state of an object. So that's a query method. Notice how we represented that. We represent methods in the third compartment. Again, we say whether they are public or private or protected or package specific. Normally, our fields are private, and normally our methods are public. There are times when fields would become public as well. We talked about this in the session on encapsulation earlier, so look at that presentation. But there are times when you would make methods private as well. These are often called as helper methods. Helper methods are methods that are often private, but they are there to support other methods in their operations. And so you normally create public methods, but also make some of these helper methods as private, and that can be used from other methods as well. Mutators, on the other hand, are methods that often modify the state of an object. For example, you could go to the person and say run, and of course the run would change the location of the person from where they are to where they will be, and so you could argue that run is a mutator. It modifies the state of an object, whereas methods like getAge are query methods. So when designing objects, we should often think about query methods versus mutators, and we can create objects with this so-called command query separation. A command query separation is where a method, which is a command on an object, you ask it to do something, and a query is where you're asking for the state or asking for a certain detail. And this is a very common pattern we use when designing objects using a command query separation pattern. And so we can model the methods of an object using these command query separators. So we talked about how this UML diagram can be represented for different classes. We only merely scratch the surface, look at classes and what's in a class, the attributes of a class, and the methods of a class itself. We'll talk about the relationship between these things and how these can be represented and what are the different intricate details we'll talk about in the next presentation. But object modeling is a lot of fun, and I find this to be extremely valuable to do in two different cases. To create these models during strategic design, to think about how I want to model the system, but I often also create these diagrams or reverse engineer code as a way to communicate with fellow programmers and other people involved in the application development, so we can exchange ideas and see if a particular design is really a good design, or we should refactor it and make it better. So this can become a really nice communication tool. This is also very useful for us to comprehend details when things become a little bit complex. Drawing a little sketch, often I draw a napkin and put little diagrams on it so that I can put my thoughts into paper, and then once I really understand how things work, I often discard it and move on. But it depends on the criticality of the application for us to decide whether our diagram should be kept a lot more ritually, or if it's something we could be very flexible and lightweight about. But in general, make sure the diagram you create is meaningful, very practical, lightweight, geared towards communication and effective use. Don't dump all you can think of in a diagram. Feel free to create multiple diagrams for various different aspects if that helps you. But every single diagram should be very minimal and focus only on the essence, so somebody looking at the diagram can understand the very important details and not be distracted about details they shouldn't be caring about in that particular context of discussion or the view that we have when we are looking at a particular diagram.